On each spin of the spinner shown, the arrow is equally likely to stop on any one of those four numbers. Deanna spins the arrow on the spinner twice. She multiplies together the two numbers on which the arrow stops. Which product is most likely to occur? Well, the first time you spin it, it's got to have any of those four numbers, and the second time you spin it, again, it's going to have any of those four numbers. So there's a total of 4 times 4, 16 possible outcomes in terms of the two numbers that will result. So since there's 16, which isn't really that many, I can write them all out. So the first one, 1, 1, 1, then 1, 2, 3, 4. If the first time it lands on 2, the next time it could land on 1, 2, 3, 4. And similarly, right? 3, 3, 3, 3, 1, 2, 3, 4. And then the last one is 4, 4, 4, 4, 1, 2, 3, 4. So these are the outcomes, 16 of them. Now what I'm going to do is for each, write the product, because we're multiplying those two numbers and then looking at what do we get. So this is 1, 2, 3, 4. 2, 4, 6, 8, 3, 6, 9, 12, 4, 8, 12, and 16. Now, of these products, they're saying which one is the most common. Well, looking through this list, it looks like 4 appears 3 times, and I don't think any other product appears 3 times. A lot of them appear twice, but I think 4 is the only one that appears 3 times. So that's the product that's most likely to occur. So number 19, the answer is 4, which is B. A spinner is divided into 3 equal sections as shown. An arrow is attached to the center of the spinner. The arrow is spun twice. What is the probability that the arrow lands on the same color twice? Well, let's see. There isn't that many, so we can write out all the possibilities. Red on the first, red on the second. Red on the first, green on the second, red on the first, blue on the second. Green on the first, green on the second. Green, blue, green, red. And then blue, 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 red, blue, green. Okay, it looks like I have 9 possible ways, and which ones are having the same color twice? This one, and this one. So 3 of them. And that would be 1 over 3. So notice the spelling of color. You know it's a Canadian exam when they put a U in there. Number 15, the answer is D. Carolyn has a $5, $10, $20, and $50 bill in her wallet. She closes her eyes and removes one of the 4 bills from her wallet. What is the probability that the total value of the 3 bills left in her wallet is greater than 70? Well, we've got 5, 10, 20, and 50. And let's say we write the bill that is removed here, and then, of course, the value of the remaining bills. If the bill removed is a 5, the remaining bills will add up to 80. If the bill removed was a 10, the remaining bills will add up to 75. If the bill removed was 20, the remaining bills will add up to 65. And if the bill removed was 50, the remaining bills will add up to 35. So obviously we have 4 scenarios. Of those scenarios, only 2 are greater than 70. So the probability is 2 over 4. And in lowest terms, of course, that is 1 over 2, which in decimal format is 0.5. So number 14, the answer is A. Ben participates in a prize draw. He receives 1 prize that is equally likely to be worth 5, 10, or 20. Jamie participates in different prize draws. She receives 1 prize that is equally likely to be 30 or 40. What is the probability that the total value of the prizes is exactly 50? So Ben and Jamie, 5, 10, and 20, 30, and 40. So the combinations would be 5 and 30, 5 and 40, 10 and 30, 10 and 40, or 20 and 30, and 20 and 40. Now let's add them up, the sums. So the sums would be 35, 45, this sum is 40, this sum is 50, This sum is 50 and this sum is 60. So of the 6 possible ways of getting a sum, 50 happens twice. So 2 out of the 6 or 1 out of 3. So number 17, the answer is B. Sam rolls a fair 4-sided die containing the numbers 1, 2, 3, 4. Tyler rolls a fair 6-sided die containing the numbers 1 through 6. What is the probability that Sam rolls a larger number than Tyler? Okay, there's not going to be that many. We've got Sam and Tyler. Sam has 4 possible outcomes, and Tyler has 6. So 4 times 6, 24. So there's only 24, so we can write them all out. It's not that many. So let's write them all out. Sam and Tyler, their outcomes, and then we will manually count which ones have this scenario where Sam rolls a larger number than Tyler. Okay, so 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6. 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6. And then all threes, of course. And then 1, 2, 3, 4, 5, 6. And then last one is all fours for Sam. And then, of course, 1, 2, 3, 4, 5, 6. Okay, now what we have to do is find out which one of these is such that Sam's roll is greater than Tyler's roll. Okay, this one, this one, this one, this one, that, and that. Those are the only ones where Sam rolls a number greater than Tyler. Greater than, larger than. Well, of the 24, how many did we circle? 6. And that's it. 6 over 24. That's our probability. And of course, in lowest terms, that's 1 over 4. So number 20, the answer is E. On the grid shown, Jane starts at dot A. She tosses a fair coin to determine which way to move. She tosses a head, she moves up. She tosses a tail, she moves right. After 4 tosses, Jane will be at one of the 5 dots, P, Q, R, S, T. What is the probability that she'll be at dot R? All right. So we have P, Q, R, S, and T. So the only way to get to P is to go 1, 2, 3, 4. 4 up. And how do you go 4 up? By having 4 heads. Because if you toss a head, you move up. Okay. And then tail is very similar. Or T, I should say. The only way to get T is to go 4 across. How do you go across? By tossing a tail. So you have to toss 4 tails. So T, 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 T. Now, if we have 4 moves, each move can be either a heads or a tails. So I have 2 choices for each move. So the total number of moves is going to be 2 times 2 times 2 times 2, which is 16. For P, it looks like there's only one way. And for T, it looks like only one way. So the remaining 14 must be these guys. So let's figure them out. How do we get to Q? Q looks like you're going up 3 and then across 1. Or going up 2, across 1, and up 3. But bottom line is you're going to go up 3 in some order and across 1 in some order. So the tails can be anywhere as long as there's one of them. So these are the sort of the combinations, as you can see. H, H. So that is actually 4. And S is very similar. It's up 1 and 3 across. So that means it's 1 H and 3 tails. So in a very similar way, you can get the combinations of moves that would take you to S as follows. Oops, put too many H's there. And then we have the H, T, T, T. And then that is, of course, also 4. So you don't even have to do R. If you really wanted to, you can. But I already have everything I need. If this is 1, this is 1, this is 4, and this is 4, then this must be 16 minus 10. Because this 1 plus 4 plus 4 plus 1 is 10. And 16 minus 10 is 5. Or sorry, 16 minus 10 is 6. So this will be 6. Now, just for the sake of completion, let's just write them out. this is going to be a situation where you have 2 heads and 2 tails, right? 2 up and 2 across. So that you can write them either as H, H, T, T, H, T, H, T, or T, H, H, T, T, H, T, H, T, T, H, H, and finally the one where the 2 T's are in the middle. And as you can see, that is 6. So in a very complete way, we were able to figure out that the probability of getting to R is 6 out of the 16, which in lowest terms is 3 over 8. So number 20, the answer is B. Betty is making a sundae. She must randomly choose one flavor of ice cream, chocolate or vanilla or strawberry, one syrup, butterscotch or fudge, and one topping, cherry or banana or pineapple. What is the probability that she will choose a sundae with vanilla ice cream, fudge syrup, and a banana topping? Any probability question is in the form of a fraction usually, unless it's 1 or 0. And the bottom, the denominator, will be the total number of choices. So in our case, we have 3 possible flavors of ice cream, 2 possible syrups, and 3 possible, toppings. And then on the numerator is our specific condition. We want vanilla ice cream, which is one of the flavors, and we want fudge syrup, which is one of the syrups, and we want banana as one of the toppings. So this is our probability. When you do the math, it becomes 1 over 18. So number 14, the answer is A. Luke has red marbles and blue marbles in a bag. If he chooses a marble at random, the probability that he will choose a blue marble is 2 over 5. Luke adds 5 blue marbles to the bag and removes 5 red marbles. If he chooses a marble at random, the probability that he will choose a blue marble is now 3 over 5. How many marbles are in the bag? So we have red and we have blue. And we are told that initially there is a certain number such that if he chooses a blue marble, the probability becomes 2 over 5. So I don't know the number, so I'm just going to write 2x and 3x. Because if I use those values, it would become 2x over 5x, correct? How many blue? Over the total, which is 2x plus 3x. And this, of course, the x is canceled to give just 2 over 5. Then they're saying that Luke adds 5 marbles, so this becomes plus 5. But then he removes 5 red marbles, so this becomes minus 5. So this total is now 2x plus 5, and this total is 3x minus 5. So now the probability, they're saying, of getting a blue marble is 3 over 5. So 2x plus 5, this guy, over the total. And the total this time is 5x minus 5 plus 5. Well, the 5's cancel, interestingly. So the total is just 5x. And that is 3 over 5. So we have to now solve for x. Cross multiply and you get 15x is equal to 10x plus 25. And therefore this is 5x is equal to 25. And therefore x is equal to 5. So how many marbles are in the bag? Well, which bag are they talking about? Are they talking about initially or later? Interestingly, both scenarios, the total is 5x. So I guess it doesn't matter. If x is 5, then 5x is 25. So 25 marbles are in the bag in both scenarios, in the beginning and after the addition and subtraction. So number 20, the answer is E. A game is said to be fair if your chance of winning is equal to your chance of losing. How many of the following games involving tossing a regular 6-sided die are fair? You win if you roll a 2. Well, there's a 2 out of 6 chance that you will roll a 2 on a fair die because there's 6 sides and each of them have a number from 1 to 6. You win if you roll an even number. There's 3 even numbers on a die out of 6, and that is indeed 1/2. You win if you roll a number less than 4. The numbers less than 4 are 1, 2, and 3, so that's 3 out of 6, and that is 1/2. You win if you roll a number divisible by 3. The only numbers divisible by 3 on a die are 3 and 6. So there's 2 of those numbers, so 2 out of 6. So which one of these have a probability or chance of a half? It's just this one and this one, so 2 of them. So number 18, the answer is 2, which is choice C. A circular spinner is divided into 8 equal sections as shown. An arrow is attached to the center of the spinner. The arrow is spun once. What is the probability that the arrow stops in a section containing a prime number that is odd? So we want prime numbers that are odd. All right, let's circle them. 2 is a prime number, but interestingly, it's the only prime number that's even. 3 is a prime that's odd. 4 is not a prime. 5 is a prime that's odd. Well, every prime number is odd after 2. 6 is even. 7 is a prime. 8 is even. 9 is not a prime. So of those 8, only 3 are prime and odd, and there's 8 of them in total, so the probability is 3 over 8. Number 14, the answer is C.